Welcome. In this third tutorial, we will explain how to use truth tables to determine the validity of hypothetical and disjunctive syllogisms. So let's begin with an example. If P, then Q, P, therefore Q. First step is to fill in all the values for P and Q. So we true, 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 false, false, true, false, false. Then, using the rules which define what the horseshoe, this symbol right here, means, using those rules that we talked about in the first tutorial, we fill in column 3. So we get true, false, true, true. Okay. Step 2, we look for a row which is consistent with the validity of the argument. That is, a row where both the premises and the conclusion are all true. And we find such a row A. Everything here, both premises, if P then Q, P, they're both true, and so is the conclusion true. So is the conclusion Q, which is also true. But again, just because everything is true in a deductive argument, that doesn't mean that it is a valid argument. To determine if it is valid, we have to go to step 3. And here we look for a row where both the premises are true and the conclusion is false. If we find one, we know it's invalid. If we can't find one, then since we've exhausted all the possible ways that true and false can be combined in these 4 rows, we know that the argument must be valid. And so examine this argument at your leisure, and you'll see that in all cases where the conclusion is false, which would be here and here, you also have at least one false premise. In this case, in row B, here your premise, P horseshoe Q, is false, and in row D, P is false. Therefore, this argument is valid because there is no row where the premises are true and the conclusion false. Contrast that with the second argument, if P then Q, Q therefore P. Again, fill out the truth table just as we did previously. Look for a row which is consistent with the validity of an argument, that is, a row where both premises and conclusion is true. And you find that in row A again. Everything's true. But that doesn't prove that the argument is valid. Okay, because when you look at row C, okay, your premises are column 3, if P then Q, Q therefore P. But if you look down here at row C, first premise is true right here, second premise is true, but the conclusion is false. That proves that the argument is invalid. Thank you for listening to video 3, the tutorial 3. The final one will look at something a little bit more complex, but it's not scary. It shouldn't be difficult if you take it step by step. Thank you. Bye.